All right, so here we are. We've got a conservation of momentum problem. We've got some asteroids, problems hitting, that kind of a thing. Let's go ahead and actually go through the formulas. One small hint I want to give you on momentum problems. Just notice, number one, if there are two masses in these problems with momentum and impulse, you're going to want to use conservation of momentum. If you only see one mass, you're going to want to use momentum impulse. That's kind of how it works. So for example, in this problem, I don't like the way it's stated here. Let's state it IB language. M1V1, M1U1 plus M2U2 is M1V1 plus M2V2. Now we have these we have an astronaut, mass 70 kilograms, moving to the right at 3, hits an asteroid, they come to a dead stop, we want the mass of the asteroid. So M1U1 plus M2U2 is M1V1 plus M2V2. We've got a 70 kilogram asteroid moving right at 3. We've got this asteroid moving to the left at 2, hence the negative sign. And then they both come to a stop. So this is 210 plus negative 2m equals 0. And now we can isolate 210 is 2m. So the mass of the asteroid is 105 kilograms. That's an introductory momentum problem. And now for the impulse momentum theorem type problem. Let's see. We have one up here. We've got a bouncy ball. It falls. It hits the ground. And then it bounces back up. So again, 10 meters per second downwards, 10 meters per second upwards. That's just not very neat. 10 meters per second downwards, 10 meters per second upwards. We're going to give a negative sign there because it's downward speed. Now let's get the contact force with which it hits the ground. We're going to use the impulse momentum theorem. I don't like this phrasing here. I like it written better as, there you go. So we're going to say F times 0.02 is 0.05 times 10 minus 0.05 times negative 10. Continuing, we have F times 0.02 is 0.05 times 20 when you use distributive property. And that ends up being 1. So when we isolate F, we end up getting 50 newtons of force. So this is kind of the basics of impulse and momentum, and we'll be taking a closer look at this on Monday.